Q is the reaction quotient. It helps us look at a reaction and determine if it is at equilibrium. And this is an important number, the value of Q, and it will be with us for the rest of the semester. All right, so the reaction quotient is basically the same as the equilibrium constant expression, except it's not at equilibrium. It's under any conditions, and we can use it to compare to K to see if it's at equilibrium. All right, so let's take this reaction, and I can write the Kc expression. Here I have emphasized that it's related to the equilibrium concentrations. If we have the equilibrium concentrations, then that will give us the value of the equilibrium constant. But Q is the exact same formula, products over reactants raised to their coefficients, only it's not at equilibrium. So when a reaction is taking place, Q tells us which direction it needs to go. So we've thrown in some reactants and products, or at some point during the reaction, we've taken a measurement and we're not sure if it has reached equilibrium yet. We plug it in and get a value for Q, some number, and then we can compare it to K to see whether the reaction is at equilibrium, or if it's still proceeding in the forward direction, or if it's proceeding in the reverse direction. And this is what we will use. So if K is less than Q, then we need the reverse reaction. So let's think about that. It's products over reactants. So if K is less than Q, that means Q is a big number and needs to get smaller in order to reach K. So the only way to take this expression and make it smaller is to decrease the products and increase the reactants. Well, if you're decreasing products and increasing reactants, then you need to go in the reverse direction. And if you put it in the order of K compared to Q, then your greater than or less than sign will point in the direction you need to go. All right. If they're equal, then we know they're at equilibrium. If K is greater than Q, then we know our reaction is not finished yet. So if our K is bigger and our Q is smaller, then Q needs to get bigger to get to equilibrium. And we know that in order to make this relationship or this ratio bigger, our products are going to have to increase and our reactants are going to decrease. So if our products are increasing and our reactants are decreasing, we would go in the forward direction. So again, the greater than less than sign points in the direction you need to go. If you'd like more information about Q, then you can type in this address for a video that will give you a lot more detail on what it is and how to use it.